Hey guys, how's everyone doing? So I'm back with you guys today to go through the second laboratory in our course. I'm going to go ahead and share my screen and we can get started. So this lab is titled Faster Plop Plop Fizz Fizz, a scientific method investigation. And you can find the material for this lab, including this PDF and your submission post lab sheet. So I have some questions and things for you guys to fill out in the bottom of the week 5 folder. And if you guys have any questions, as always, email me and let me know. So let's get started with kind of going through this. And um, I'll go through it as an overview, but feel free to stop and start this video as you see fit to read along. So the overview of this lab is pretty straightforward. The scientific method is an approach to answering a question. Science is an evidence-based discipline that attempts to build a better understanding of the natural world and how it works. And so in this exercise, we're going to be using the scientific method to investigate the rate at which Alka-Seltzer tablets dissolve in water, and to identify the factors that affect this rate. So after we do an initial experiment together, you guys will go ahead and develop a second question and then apply that scientific method to answer, or at least attempt to answer that second question. So I'll let you read through these outcomes, which are pretty important. I mean, the biggest thing is, the main outcome for this is going to be working through the scientific method and identifying the steps of the scientific method, and how you would use that to conceptualize and think about a question that you have, build a testable hypothesis based on what you know, um, and then figure out a way or plan out a series of experiments to test that hypothesis, gather some data, and then allow that data to inform whether your hypothesis about that question was correct or incorrect, revise and repeat. All right. So the time requirements for this, gathering everything should take you about 15 minutes. Activity 1 should take you about 30, and activity 2 should take you about another 30. So we're looking at about an hour and 15. The only personal protective equipment or PPE that we're going to need for this are goggles. All right, so you can find the goggles in your lab kit. So I'm going to allow you guys to take some time to read the background. So if you haven't done so already, feel free to pause the video and read through the background. But pretty much the background walks you through what the scientific method is. It'll talk about really how we use the scientific method every day in every aspect of our life, just making observations and forming questions about things we see in the world. And the scientific method just kind of takes that a step further in thinking about how could we answer those questions? How could we address those problems? Talks about building something or defining something known as a hypothesis, so something that you can test. And a hypothesis is a prediction based on your content knowledge or what you know about the situation, about how you think the question would resolve. But the purpose of the hypothesis is to then test the hypothesis. And when you're thinking about hypotheses, right, it's always important, especially in relation to science, to think about a hypothesis that is testable, that is directly testable. And so when you get to part 2 of the experiment, you guys will be coming up with your own hypothesis. So we talk a little bit more about some variables as we did in the previous graphing lab. You want to have a testable hypothesis. And it kind of walks you through some examples of what are testable hypotheses. And it kind of just describes the experiment that we're going to be doing. So pretty much the name of the game is we're going to be asking the question, how does temperature affect the dissolving rate of an Alka-Seltzer tablet in water? So how does the temperature of the water affect the rate at which the tablet dissolves? All right. And so we need a couple things from this for this experiment, all of which should be in your lab kit, except for one thing that I didn't have, and I'll tell you that. So Alka-Seltzer should come in these little packets, a 250 milliliter beaker, a thermometer, a wax pencil, and I didn't have plastic cups in mine, so I got some red Solo cups here. And you'll need 6 of them, 3 for the first part and 3 for the second. Okay, so things that you do need but are not supplied to you. So you'll need to make an ice water bath, you'll need hot tap water, and you'll need some sort of timer. So I'm just going to use my phone on the stopwatch feature. But, if you have a kitchen timer or things like that, those work well. Again, safety wise, you need your goggles. And also, very important safety wise, don't consume anything that you use in this lab or any other lab within this kit or within your educational career. You don't know where any of this stuff has been, even though these are Alka-Seltzer tablets. You don't know what they've been around. You don't know what they've been exposed to. You don't know where they've been sitting. So don't put them anywhere near your mouth or your face. Also, don't touch them. Then don't touch them with your hands and then touch your hands to your face. And if you're using something like your cell phone for this, make sure you wipe your cell phone down afterwards and wash your hands. All right, so preparation, clean and sanitize your workspace. That's always going to be important just because you want to make sure that there's nothing in the workspace that you can ruin potentially, or that could ruin your experiment. Read all the instructions. Absolutely. So if you haven't done so already, pause the video here and read through all the instructions. That way you know what's coming up. All right, so you've read all the instructions by now, and obtain the materials. So go around and gather these materials, make sure you have them all laid out. Like I have everything I need here. The other thing that you will need is a knife. So a kitchen knife will do just fine to cut the tablets. So activity 1. Temperature versus time to dissolve, setting up the experiment. So 3 different temperature baths will be prepared with approximately the same amount of water in each. Ideally, there should be about a 50 to 60 degrees Celsius difference between the cold and the hot temperatures. Okay. So we will try to accommodate that. So label the 3 cups, cold, hot, and room temperature using the wax pencil. So we got cold, hot, and room temperature. Okay. I'm going to put those off into my little workspace here. So it's a good idea to have a dedicated workspace. So I'm working on my kitchen island at the moment. But, wherever is convenient for you. Just for warning, you're working with water, so maybe don't be near anything that you can ruin with water, like a laptop, in which I'm recording on right now. Okay, so obtain our timing device. So we got that. Make an ice bath by adding ice and at least 300 milliliters of cold water to a bowl or cup. All right. So reading ahead, I'm going to skip that step right now. I have some water in the fridge with some ice in it that I did ahead of time, but I'm going to let that sit in there until we're ready. And I'm actually going to make a little bit of an edit to the procedure. So if you're following along, I'll go over what that is, just because I think it's going to be a little bit easier to do, at least as a first pass. All right, so open the Alka-Seltzer tablets. All right, so there's 2 per. So we're going to open that. All right, and it looks like mine broke in kind of. All right. So we have our Alka-Seltzer tablets. I have them just on a plate. Carefully break each tablet into 2 pieces. So this is where the knife comes in for a tip. Okay. So to break the Alka-Seltzer tablets in equal portions, take a sharp knife or scalpel and lightly score a line on the back of the tablet. Repeat the process several times. Using light pressure, break along in half. So we're going to do that. If there are major size differences, just make them as observations. So you're essentially sawing your Alka-Seltzer tablet. It should be soft enough if you have a nice sharp knife. And then we're going to break it directly in half. Like so. You know, they're not going to be perfect in size, so get it as close as you can. Okay. It's pretty good. All right. I'll put that knife off to the side. So using your 250 milliliter beaker, you're going to measure 200 milliliters of room temperature water from your tap and pour it into a room temperature cup. So what I actually did was I put some water in a bowl and I just allowed it to get to room temperature while I've been sitting here. All right. I advise you to do this over a sink to prevent any spillage, but we're going to the 200 milliliter mark, and then we're going to put that water into the room temperature cup. So I will be right back while I do that. So I have 200 milliliters of water going into my room temperature cup. Okay, room temperature cup can sit there. All right, and so now this is where my little adaptation to the procedure is going to kick in, right? The way that the procedure is written is it has you do all 3 at the same time. And I think that's fine for the second and the third trial. But I think for the first time, do them separately. Feel out the procedure, feel out what you have to do. All right. Now, I didn't print out my data table, I wrote it out. All right. But what you need to do before you run anything is take the temperature of your water. Okay. So at room temp, we're going to drop it in and we're going to see what the temperature is. Now, remember, this is Celsius is going to be our temperature. All right. And the goal is just to kind of set it in the water, give it a few minutes to acclimate. You don't want to be touching the thermometer because the heat from your hand is going to affect it. And then we'll time for our first run number, the room temperature cup. All right. So this water is definitely below room temperature, but it's from a faucet, so that's understandable. And we're looking at about 20 degrees Celsius. So standard room temperature is going to be around 37. So this is pretty significantly lower. It's on the cold side, but you know, get as close as you can. All right. So let's go ahead and we have our timer. Okay, hold on. We have our timer and we have our cup. We're going to go ahead and drop in one of the tablets. I'm not going to hold this up because I don't want to spill it. And we're going to record the time. All right. So from the moment you drop it, start your timer. And when it fully dissolves, you end it. Okay. So let's see what we see. So I got my timer going. I don't know if you can hear, but it's bubbling. Right. And we're just watching it dissolve. Pretty basic, pretty simple. You don't want to be moving it around because you don't want motion to influence the rate of dissolving. Remember, we're looking to control all other variables besides temperature. So we'll know it's fully dissolved when we stop seeing any fizzing or bubbling. All right. So I'm fully dissolved at around 46 seconds. All right. Now your times might vary depending on the size of your tablet and the temperature of your water. So just because I got 46 doesn't mean that 46 is the correct answer. And that's always important to remember whenever you're doing a scientific experiment. What you get is what you get. All right. And any differences in that, we're going to rule out by doing more than one run and taking an average. All right. So our room temperature is done. So what we're going to do is we're going to dump this water. And we can dump that right down the drain. And we're going to move on to our hot water. So for this, what I'm going to do is I'm going to get 200 milliliters of hot tap water. So I'm just going to step off screen for a minute. So I'm going to run some tap water, let it get hot, and then that's what I'll be taking for this experiment. All right, so we're going to run and let that get hot. But again, remember, everything that you're doing, you want to try to minimize any other variables. So moving the cups, you know, not starting your timer right away or delaying the start of the timer. Major differences in Alka-Seltzer tablet size, major differences in water size. It's not critical that you're exactly at 200, but you don't want one being 250 and one being 100. You know what I mean? So try to be as controlling on those other variables as you possibly can. All right, so I got 200 milliliters of hot water. So I'm going to put that in my hot cup, marked with the H. And I'm going to drop the thermometer in there, and I'm going to see what the temperature is. All right. Now I can feel the water, so I know the water's hot. No, it's not boiling. Don't boil water to do this. You don't want to hurt yourself. All right, so I am right at about 40 degrees Celsius. All right. Again, not crazy high over room temp, but for our baseline of room temp, it's high. So same thing that I did before. I'm going to drop the Alka-Seltzer tablet in, and I'm going to start the timer. All right. So it's dropped in, timer started. You know, make some observations as well. You know, is the fizzling louder? Is the tablet floating to the surface? All right, and we're out. We're at about 20 seconds. All right, so remember our room temperature was at 46 seconds. That's a pretty big difference. You know, and for observations, I'm writing louder fizzing, right? Because it just sounded louder. So again, now you can dump your hot water. All right, and we're going to move on to the last one, which is our cold water. All right, so I've had some ice water sitting in the fridge, so I'm going to pull that out. I'm going to measure 200 milliliters of it, and then we're going to see what that does. All right, 200 milliliters of cold water. That's going into our plastic cup. And we need our thermometer. So let's see where we are at for this one. So temperature wise, all right. We're still going down here. So we are right about 0 degrees Celsius. So now remember, the recommendation was about a 50 to 60 degrees Celsius different. I didn't hit that here, but that's okay. You can still run it. My suggestion, maybe get a little hotter with the water, but I didn't let the hot water run long enough, apparently. All right, so we have our timer. We have our Alka-Seltzer tablet, and we're going to drop it in, and we're going to start. All right. So now right off the bat, I can observe that the fizzing is a lot quieter. All right. With the hot water, the tablet kind of floated immediately to the surface. For the cold water, it's not. It's staying down at the bottom. What does that mean? I don't know, but that's an observation to record. All right, so we are definitely going to get past our room temperature time, and we are far beyond our hot water time. But we're going to observe it. We're going to record it all the way through. Still going. We're starting to get down to the bottom. Starting to get to where there's not much of the tablet left. All right. So we're at 2 minutes and 19 seconds. So we're being asked to record in seconds. So 2 minutes and 19 seconds. It's going to be 120, 139 seconds. So through one trial, that's what my data table is looking like. All right. So I'm going to give you guys a chance to kind of rinse and repeat. You're going to do this 2 additional times for each temperature of water, try to get the temperature as close as you can to each other. But if you're a little off, that's not a big deal. And once you're done, down here in the bottom of data table 1, you're going to calculate your average. All right. And so remember how we did that from the last lab. You're going to add up your totals. So, if you had like for hot, for example, you had 40 degrees, 45 and 50, you'll add those up and you'll divide by 3, and that's your average. All right. So once you're done that, pause the video until you're done that, I should say. And then once you're done, we'll move on to part 2. All right. So if you're back, then you've just completed all 3 trials and calculated your averages, and you've completely filled out data table 1. So good job with that. Now we're going to move on to activity 2. And activity 2 is something that I'm going to allow you guys to do independently, because I don't want to take a hypothesis or a research question from you, because there's definitely a finite amount of options here. So testing the new hypothesis. The first thing that you're going to do is you're going to list 5 questions about the rate at which Alka-Seltzer tablets dissolve. So what 5 variables do you think could impact the rate of the Alka-Seltzer tablets dissolving? We just did temperature of the water. There may be some other things. If I were to think off the top of my head, I could see size of the tablet. I could see amount of water. You could do, let's see, whether the water is already used, meaning is it cold water that a tablet already dissolved in? Or is it clean tap water like we've been using? What else? Maybe you're not dissolving the Alka-Seltzer tablet in water. Maybe you're dissolving it in some other liquid medium. That could impact the rate of dissolving. So there are plenty of other options for you guys to explore here. That's just a few if you guys are struggling. So think about the controlled variables, right? So what else are you going to hold as a controlled variable if you change with a new question? What would happen if temperature were held constant and one of the controlled variables were now changed? Yeah, so we had a number of control variables in activity 1. Think about what happens if you would change them. So number 2 is develop a new hypothesis based on one of those questions, right? So what controlled variable from activity 1 do you now want to change, and see how that impacts the rate of dissolving of the Alka-Seltzer tablets? So remember that a hypothesis must be testable with empirical or measurable data. Yeah. And really your measurement can be the same. Your measurement could be time of dissolving. I think that's pretty clear. And we're able to do that with the supplies we have. So then you want to fill out activity table 2. So you have your list of questions. From that list, pick one thing that you want to test, one independent variable that you're going to change, and state a hypothesis about how you think that variable will impact the rate of dissolving. Identify that independent variable here. Identify the dependent variable. It's probably going to be rate of dissolving or time to dissolve. If you want to do something else, feel free to do it. Get creative with it. List all of your control variables. What are you going to keep constant in this experiment? Temperature of the water is going to be one of those things. How will you measure the dependent variable? If it's time, are you going to measure it with a stopwatch like before? If it's something else, how are you going to measure it? And describe the expected results if your hypothesis is true. So you might say, for instance, right, let's say we're saying amount of water. You might say the rate of dissolving will increase as I increase the amount of water that the Alka-Seltzer tablet is being dissolved in. So the expected result would be if I put, if I'm comparing 300 milliliters versus 200 milliliters versus 100 milliliters, the Alka-Seltzer tablet's going to dissolve faster in 300 milliliters than it would in 200 milliliters. And 200 milliliters would dissolve faster than it would for 100 milliliters, something like that. Then you're going to test this hypothesis. You're going to redo the experiment pretty much but for your new research question. And you're going to fill in data table 2 accordingly. But again, I'm going to let you guys do that yourself. But that's it. That completes your scientific method investigation lab. So if you have any questions while you're going through this lab, feel free to let me know. Again, all the material for this lab is in week 5 folder on the Blackboard page. I hope you guys have a great rest of your night. And again, if you have questions, let me know. Take care, guys.